In section 17.6, we are going to look at a couple reactions that demonstrate the acidity of carboxylic acids. So we're going to look at two reactions that carboxylic acids can do that show them being acidic. One reaction is the carboxylic acid reacting with water. And the other one is carboxylic acids reacting with a strong base. So for the reaction with water, I'm going to use just this little carboxylic acid because it's easy to draw, but this reaction is the same for any size carboxylic acid, no matter how big it is. So this would be any carboxylic acid. And when we react any carboxylic acid with water, the reaction is an equilibrium reaction, which you learned in Chem 121. That meant that the forward reaction and the backward reaction are both taking place at the exact same time. The products of the forward reaction are the carboxylic acid having lost the hydrogen on the OH. After the carboxylic acid loses its hydrogen, it's left with a negative charge, so it's an anion. And the other product of the reaction is H3O+, which you might recognize as being a common product in acid-base reactions. The H3O+ is formed when the hydrogen from the carboxylic acid moves over and joins up with the H2O, so that turns it into H3O. The hydrogen also carries a positive charge with it, so when it moves over to the H2O, we end up having a positive charge. So that is the reaction of carboxylic acids with water. And with a strong base, we're going to use the same little carboxylic acid for the strong base reaction. But again, this could be any carboxylic acid, any size. And the strong base that I'm going to use in this example is NaOH. That's a very common strong base, sodium hydroxide. I'll give you a list of a couple others that you might see. Now, this is not an equilibrium reaction. This is a straightforward reaction. And in this reaction, we get the hydrogen from the carboxylic acid, the OH, trading places with the sodium of the base, the sodium hydroxide. So we get the hydrogen of the carboxylic acid trading places with the sodium from the sodium hydroxide. So these two guys are just trading places. Now this HOH, that's just another way of writing H2O. It's like a condensed formula, HOH and H2O. It means the same thing. You may also see, so this product right here, sometimes it might be written as O minus, Na plus, or it's just showing you the cation and the anion of that compound. That's kind of similar to somebody writing NaCl or writing Na plus Cl minus, where we're just showing exactly what the cation is and what the anion is and what their charges are. So this form with the charges is exactly the same as this form right here without the charges. They're both representing the same thing. So these are the two reactions that carboxylic acids can do with either water or strong bases. Let me give you a list of some other strong bases that you might see. Other strong bases, there's not very many that you would see. Lithium hydroxide, LiOH, and potassium hydroxide, KOH. And I think those are really the only three, those two and NaOH, those are the only three that you're going to run into. So with regards to this reaction, the carboxylic acid reacting with strong bases, this is actually how we go about making soap. Soap is the molecule that is made when you react. It is the product of the reaction between a carboxylic acid and a strong base. It's not quite as simple. If we're talking about making an actual soap that a consumer can use, it's not quite as simple as just picking any carboxylic acid and mixing it with a strong base, and then ta-da, you have soap. It's a little bit more involved than that. The carboxylic acid, in order to make a good soap, the carboxylic acid that you start with needs to be one that is not soluble in water. Even though the carboxylic acid is not soluble in water, the soap always will be soluble in water. And the carboxylic acids that are not soluble in water are typically ones that are just really, really big. So I'm going to draw a really long 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 carbon carboxylic acid. So that's really big. And let's react it with KOH. And the product of this reaction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, OK, plus water. The product of this reaction, this looks like it would be a pretty good soap. This carboxylic acid, definitely not soluble in water. We just find that the cleaning power is much better for a soap when it has a really long carbon chain like this guy does right here. Now, if you're excited to talk about soaps, that's cool. We are going to talk about soaps. Not really so much right now. So we're not going to really get into soaps until for another couple chapters. We are going to come back to it. We're just talking about it a little bit right now. What